Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you're new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate Forum. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Slick James Johnson, Paul, Flatten Earth, Ibon Kim, Conspiracy, rest of your name I don't remember, Chocolate Saying, Arwin and Anon Moto. Good to have you all.
Hello.
Hello, hello.
Hello. We did a rough order of housekeeping on the last show, so I'm going to hopefully we'll keep this concise. We'll see how we get on. Any signs of curvature?
My wife?
Any signs of Earth-based curvature?
No.
Any more? Anybody? Anybody at all? Got new panel members from
Nope.
last time? Any signs of axial rotation, again, of the Earth-based variety?
No.
Any signs of an axis?
No, we're definitely not spinning. Stationary, everybody on the panel stationary?
Stationary.
What about scientific evidence of gravity?
I dropped
Nothing.
the microphone once.
Yeah, gravity, not relative density.
Oh.
Any scientific evidence of gravity? No?
Nothing that I can
None
think
at all.
of.
There was a
only,
movie.
Only in a contraption.
Only observed in a contraption, you say? I'm sure we'll hear that again on this show. What about any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
I saw a movie called Core.
Core? That's a new one.
No, it's an old movie called The Core.
No, it's an
That's
old
what they had
movie.
to do. They had to go jumpstart the molten iron core, man. You don't remember?
Yeah,
No
I
way.
remember that movie.
There's
Jump
proof.
start the
Yeah.
molten
Yeah.
iron core.
They made a
No,
submarine
it's
that
called The
drilled through the
Core.
earth. They made a submarine. It was like a tunnel boring machine, a TBR, whatever the hell it's called, TBM. It goes under there, and then they shoot a nuke or something, and then they jumpstart the Earth magnetic ball or whatever.
Wow. I wouldn't take
Oh
it
yeah,
as...
you should watch it. You'll love it.
I will check it out. That sounds interesting. But man, the programming
core.
is strong in that one, eh? There's the least evidence for the molten iron core, if you ask me, of all the things on the housekeeping. That's the most preposterous.
I remember watching it as a globe head, and I'm going, "What? This doesn't make any sense."
Exactly. Even as a globe head, I was like,
As
this
a
is
globe head, I was like,
okay.
I don't know about this.
Did they explain why the molten core solidified in the first place?
No, they did. They did. It was something. I think it was caused by man. So they did something, and then they fucked it up. So then they had to go get Bruce Willis or somebody, and then they made this thing. It's amazing. It's one of those things that kind of like went under the radar. But watching it as a flatty is even funnier than watching it as a globe head.
Check it out. The core.
What?
New one on me. Any
Watching
evidence
a
of the
lot of shit.
distance? Any evidence of the distance to the sun?
No.
Right. Any evidence of gas pressure existing without the necessary antecedent of a container?
Nope.
No, you're right. We can't have gas pressure without a container. Space is fake. the assertion that the sky is a vacuum is a complete nonsense. What about the presuppositional? Go on, sorry.
Well, instead of space being a vacuum, maybe it's made out of the ether. Sorry.
Yeah, we'll segue back into it eventually.
Don't
I know
say
you're
the
keen.
Edo.
Right. Last but not least, the R value. Any evidence of that presupposition they all hold so dear to?
I know this is going to be a fun episode.
Yeah, I can sense it too.
Unfortunately, I have to go get a shower and go, but I want to have this conversation, but I got to get heading out. I would want to put myself on pause, or I'll just hang out, go shower real quick, and then come back, and then I can have this conversation on my way to work.
No worries. Hopefully catch you shortly. CGI Ranty says, any evidence of Anthony and his education system evaluation? It's not something I've asked him about recently, not in the last couple of days at least. I will get an update from him. He keeps saying he's going to come on the show and just doesn't. So, you know, I'm sure he will eventually come on and give us a full update. Might take a whole show to find out what Anthony's been doing the last couple of weeks. But yeah, hopefully he'll join us and tell us exactly what's going on with his progress with the education system. And indeed his progression through his own education. So hopefully that'll come up when he does join the show eventually. That's it. Thanks for housekeeping. Much obliged. Where's some fresh baller meat? Chocolate saying he's just... I don't know if somebody said the link was broken. I don't know if they were just lying. If we can have somebody join just to check the link works. There's a gap on the
That was me, but I posted the correct link.
Oh, is it broken?
Yeah, there's extra stuff added to the URL, so
Really?
I just removed that and reposted the link.
Oh, okay. Let's just try it again, because every time I cut it from my browser, it's just exactly as I paste it into the info box. I don't know why
Yep, your link that you just posted works. Or wait, that's just me. Yeah, the one that I last posted in that Skype is that works.
Oh, okay, I'll cut that one instead. That's in Master B, yeah?
Correct.
Okay, well, if you were struggling to join on the last show, that's take responsibility, although I don't know what I've done wrong. Link now if you want to join. Feel free. There you go, that looks more like it. That's a lot shorter. Excellent, thank you for
might
that,
have been why I
Yvonne.
couldn't get in. Mine was having trouble.
Say again, Paul?
That might have been why I was having trouble on my end. Didn't even realize it. I do want to rewind, if it's okay from the last show. I was going to share something about how the lie could be perpetuated, and actually could even explain the Jesuit schools. So they could have started out bad, but then it's just they perpetuated the lie continually. Have you seen the monkey? Here, I'll share it. I dropped it into the side chat, but I'll share the video. I won't play it, but I don't know if you've seen this. The 5 monkeys to create a mentality of 80% of the people that will call math. That's how they get the monkey, and every time the monkey tries to get to the banana, they squirt it, and then they squirt the other monkeys, and then eventually they get the monkeys, they swap out the monkeys, and they've all kind of, even though they don't know why they do it, they attack the person that tries to get the monkey. Have you seen that experiment?
I'm not sure if it's an experiment. I saw JLB, if this is the same as the 100th monkey effect or similar. I remember watching a JLB video about him.
I don't know if it's...
Go on.
I don't know if it's the 5th or the monkey effect. Go ahead.
Well,
like
maybe it's a different
the,
thing.
one of the
I mean,
monkeys...
I'd be interested to see the actual study that it did to back the validity, because it's normally like this, isn't it? Cartoons.
Yeah,
as opposed to you
but I
seeing
mean, it's
them.
just kind of interesting. I'll drop the link again. I'll drop the link.
What's the gist of it though? Basically, they train monkeys to grab a banana, and when they replace the monkeys, they already know. Is that what you're saying?
Basically, yeah. It's like they attack the monkey even though they don't know why. When it tries to get that one new monkey tries to grab the banana, the other monkeys attack it, but none of them know why. Just because the previous generation had knew every time they climbed up to get that banana, they would get wet or get punished for it. It was kind of interesting.
Yeah, it does sound like a similar deal to the 100-month key effect. I'd question the validity purely on how big a new one JLB toured out of the 100-month key effect, and it sounds like an adaptation of that. So I'm not decrying what it is. It might have complete, case studies and actual video of people squirting monkeys. You just don't know.
Right, I got you. But there was that video, I don't know if you saw it, where there was a lady who was in a waiting room, and every time the bell would go off, the other people would stand up, and they did this, and then they replaced all the people in the waiting room, and then she was the only one left, and then she started standing up every time the bell would go off, and then she actually told everybody on the row that well, we're supposed to stand up every time the bell goes off, and then eventually she convinced everybody to start standing up every time the bell goes off. It's a similar kind of experience, or similar type of phenomena, I guess that's a better way to say it.
Right, group conformity. So yeah, just like peer pressure, isn't it? Everyone else is doing it, so I should be doing it too, even though it's stupid. They've done similar studies where they had, again, JLB ripped this one to part as well, where they were showing that people in group conformity exercises, where they were shown 3 sets of lines, and you're asked which ones are the matching pair for the sake of argument, and all of the actors get it wrong. The idea of the test being to see if the actual participant in the test would also conform to peer pressure. But again, check out JLB. He's getting a lot of shout outs today for debunking these things that are asserted as such. And then when you look into the actual study, the only thing you can find in terms of validity given to it is the TV production that's being presented as though it's the test, when literally everybody on the screen is an actor, even the person pretending to be a real subject. So a lot of these things are quoted, to make you think that you've got this group mentality, psychologically speaking, when the tests that have been done may actually be the magic trick itself, to convince you that you're gonna be more conformist by natural aversion, just by human nature. We are just conformists, when it might actually be completely opposite, and it's just the propaganda of the quasi test that's put into the mainstream, so that people like you and I go, oh right, that's just how human nature is, when it might not necessarily be the case. Sorry to piss on your bonfire, Paul. Sorry.
That's okay.
One of the reasons I like JLB a lot. He hears this stuff parroted, like, no, I'm not saying you're a parrot, but I'm just saying he hears stuff like that said, and then he'll go, oh really? Why are we like that? Let's have a look into the study. Let's have a look at the actual validity this has been given. What are the tests that were actually performed? Who actually did these tests? How big was this case study? How many people were involved in the test? How broad a scope have they given the conclusion based on the number of subjects? That's the kind of thing that JLB looks into, and I think, well, I'm too lazy. I'm exactly the kind of audience member that he doesn't want. Somebody who's like, yeah, I just want to watch you do it because I'm too lazy. Precisely what a lot of flat earthers stand against, right? Do your own research. Nah, I'll just go watch JLB. Shout out to JLB.
Yeah, that was a very interesting subject, though. I found myself captivated listening to it because I've heard about quantum mechanics and all that, but I never really fully understood it. And listening to you guys talk about it, it sounds really interesting.
I'm no expert in quantum mechanics. I can understand how to pick apart something based on its adherence or non-adherence to the scientific method, and as far as I can ascertain, it's completely scientifically valid from every bit of research that I've done. Well, I'm prepared to stand by that if someone proves that to be incorrect and shows that the actual scientific validity lent to quantum mechanics is actually hocus pocus, then, I'll stand corrected. But for now, I'll say no. As far as I can tell, it seems to have driven technology that we have, and it seems to be scientifically valid. Well, I can't really say any fairer than that. That's what I've researched. So, the fact that some of it's come from, as pointed out by a non-moto, hostile sources, well, I can't decry that. I've researched that as well, and I agree. So, yeah, a lot of the things that you come up with when you're quoting sources to debunk a narrative are going to come from within certain institutes that we're actually fighting against, and that can't be helped. It's just part of the tangled web of deceit that we're fighting against. You're going to be scrambling through various aspects of that web when you try and unpick it. And, some people might criticise the nature of certain sources that I present. If I'm using, or red pill philosophy, let's get it away from anyone on the panel. So when he uses that quote from Neil deGrasse Tyson, that stuff is flat. Well, that's a hostile source, right? Doesn't mean he stands by what Neil deGrasse Tyson says. Just that particular quote in that particular instance is a way of undoing the assertion that you can go up in an aeroplane at cruising altitude and see a curve. You can't, and the heliocentric priests will declare that you cannot. You're not high enough. That stuff is flat to our vantage point and to our experience. That's precisely what we would say. But it's only the people like Neil deGrasse Tyson that get away with spouting the narrative in that overt way that is almost akin to how we will explain it. Well, you can't ever see a curve, you can't go high enough, and it's because the Earth is flat. He'll say you can't see a curve, you can't go high enough because the Earth's a ball. Or, the football didn't go through the goal. I forget if the goal was made or not, but because of the Coriolis effect. He's literally telling you that you've got two reference frames, and those two reference frames will affect a ball travelling through the air when it's released from a footballer's hand. And you're like, man, the high priests of doublespeak can get away with literally pissing a contradiction right in the face of the public and get away with it with a smile and a Freemason vest.
Gotcha. One of the things that I was interested in hearing though was Eban, you were talking about how you said electrodynamics started with quantum mechanics, but like a branch off, and I'm trying to understand what was that about.
Sure. So electro-quantum dynamics. So it's trying to describe how light and matter interact with each other. And just like, for example, if you wanted to just kind of hold on, I'm hearing buzzing. I don't know if that's me or you guys.
You.
Hello? Okay, sorry about that. So, for example, we can come up with just even simple experiments to create your own spectroscope to observe and measure the different light waves in the visible light spectrum. Now, we don't really know why and how it interacts with different mediums like air or vacuum or water or just physical matter, like, for example, say lead. And so quantum electrodynamics tries to describe it much like how we can observe certain things like the globe Earth model and measure distances and things like that. That can be, as long as we make assumptions and stuff like that, we can go ahead and measure it with whatever tools that we have. The only thing is we don't really necessarily know why it how it does. We just don't know the details, and that's why there's just an extra scientific, what is that called, field, sorry, a scientific field just kind of going towards it, because okay, we've got quantum mechanics, we know that works, we can apply it, so let's add in Einstein's theory of relativity and see if we can explain.
Really? How do you apply quantum mechanics?
You're gonna ask someone. You should probably ask someone who's a lot better equipped to answer that.
It was kind of a trick question. It was kind of a trick question because, yeah, you can apply gravity as well. Doesn't mean that it's
No, you can observe something falling, okay, or something rising, and you can apply whatever you want to it that explains that, whether it's gravity or density or whatever. The observation and measurement is a lot different than the explanation of why it's occurring.
exactly. And quantum mechanics attempts to give a filler as to what is actually happening and why. But it is
No.
ways.
It's not about why. It's about the observation and measurement of what is going on.
Okay.
No, it's
So
the how and the
you mean
why.
the double slit experiment, for example? Lou?
What do you mean about the double slit experiment?
Well, isn't that one of the things that supposedly proves that quantum mechanics is a thing?
What you don't need to prove that what you observe. You don't need to prove something that's observed. It's observed. You don't have to prove how you measure it. You just find a way to measure it, however way you want to measure it. Again, it's about the why is it occurring? How is it occurring? That stuff. Quantum mechanics doesn't really deal with that.
Oh, really? I
Okay,
thought
oh, really? Go ahead.
it just that.
Then explain quantum dynamics to me if you don't know.
Quantum mechanics, right? That's what we're talking about, right?
Yeah. So tell me more about quantum mechanics.
Well, quantum mechanics is based on a form of particle conceptualization of physical elements. So what it does is it brings forth the conundrum of the particle and the wave behavior of light, for example, or electrons.
Now is that observed or is that
Quantum mechanics then attempts to give an explanation to why that occurs based on, I think, a lot of probability concepts are
that's
involved.
quantum electrodynamics. That's not quantum mechanics.
Oh, really? How is it so different?
There's a difference. Don't ask me. You don't seem to believe me. Just go ahead and do your own research on it.
I
Just look
have,
up
and
quantum
this is the
electrodynamics.
conclusion I got. So this is new to me. I don't know. I'd hoped you'd back up more of the assertion, because I see quantum mechanics mostly as theoretical and conceptual. But yeah, there's other angles to approaching the same observations, basically. Like, for example, the type of approach that Dayan has these days. I think it makes a lot of quantum mechanical concepts superfluous to approach it in that fashion, but maybe that's just me. I'll shut up now.
I mean, I get your point. For example, atoms, we can't see it as it is. We have to use different types of technology in order to gain a grasp of how it looks, but how it functions, how light functions, how light is measured, all of that stuff. We can observe it, we can measure it, and we can apply it. As far as when you want to look into the details of
But
what it could be with whatever it is, that deals into a different field.
but
It further progresses
all these
the
things of
entire.
different behaviors of light is still pretty much based on the assumption that it is particles. And that's where the quantum mechanics really sets in.
We're observing and we're measuring particles. We're not trying to understand it. That's
Oh,
just a
really?
different field.
Oh, really? Have you observed
All right,
a
I'm back.
light particle? I don't think so.
No, they're
Observe
observing
light.
Light
You can measure the light spectroscopy. You can
right.
do it yourself. If you shine a light through a vacuum and you go, hey, is there heat emitted from it? Yes, you can. Where's that heat? Infrared. Right. So there's different things that you can go ahead and observe and measure.
Right.
quantum
And then
mechanics.
next
Anything
time you
else
assume that it is
that
particles. That's something
Anything else that tries to explain it is a different field branched off of quantum mechanics.
right. Well, I think a lot of the quantum mechanical concepts are based on that light, for example, but also the other things like
Quanta.
electrons are particles and not something else. Isolated
We
singular
have to
units.
give a
The
description of
concept
what
of
we
isolated singular units.
Yeah,
That.
quanta. That's what
We
they're
have
measuring,
to
isn't
get-
it? Individual photons hitting light detectors. That's what they're measuring. But that's not what they're trying to qualify. It's not the light itself. It's the phenomena, the wave function collapse. That's what they're actually observing. And when John last detailed this, I said to him, I think it was on Bulbous, so I was like, after the fact, I said, should you explain when you say the observed phenomena is wave function collapse that you need to detail, again, that it is a mathematical construct when you try and explain it as a waveform? You're still talking about individual quanta. You're talking about an individual particle of light hitting a photographic plate or a sensor. That's what you're talking about. But the phenomena is the wave function collapse. And the understanding that the observation itself is what causes that to happen. You get interference, diffraction, if you don't observe it. If you do, then you do. In other words, if you've got something that actually knows, a detector, which slit the particle's passing through, then it collapses. But if you don't, and you just literally observe the experiment, you don't know which one it's going through, you'll get the interference pattern. Well, it's the understanding that you having the knowledge of which one it goes through is what causes it to collapse. That is the scientific discovery. It's the establishment of that as the cause.
Right.
But that's been done through systematic experimentation that's been validated thousands and thousands of times and driven technological advancement. Whereas the other field, I'm not familiar with this, Eben. You are far more knowledgeable. You got me out of a hole because I didn't understand what the objection from Anon is. Now I'm more clear about it. I'll quiz John on it later. But there's another field that's branched off that field. Well, I didn't know that.
No, me neither. But anyway, I'd like to respond for a moment and say, yeah, there have been energy units, quantities measured, and there seems to be a minimum amount of energy quantity in order to register in one of these experiments where they measure supposedly photons. But to declare that it is a separated unit that cannot be divided any further, I think that's a false assumption.
Why? They've scaled the test up. They've done it with larger and larger and larger.
Of course, but smaller and smaller.
Well, you can't get much smaller than a particle of light, Arwin.
Right, because it won't register after a certain level of decrease. But it doesn't mean that it is a particle.
It does,
It
because you can
doesn't mean
scale it.
it's light. No.
It does, because you can scale it up in size.
Arwen,
You can go up to bigger sized matter, bigger than light, and have the same effect, physically larger.
Yeah, I get that. Okay, but I'm just talking about that. No, I'm not saying that quantum mechanics, that effect doesn't work. I'm not stating that because I do believe it works. I've seen it demonstrated, class. But that light is a particle, a photon, that it is a singular isolated unit. I attest to that. I mean, I disagree with that.
And
Okay,
this
fine.
is like the whole vacuum of space thing, where it's like we're getting bogged down with like how many sensors does the Voyager satellite have, when Nathan can just say, and rightfully so, that the whole vacuum is a farce. So there's a thing. It's like Jenga. You pull one thing out, the whole thing from the top collapses. And that thing for me, until I get a proper answer that actually I understand, this is my problem. Is if you have a particle, if it's a particle moving through anything, ether, water, whatever, then it changes speeds when it goes through that, and that's not something made up. This is like known fact that speed of light, c, is only in vacuum. So c changes, different mediums change the speed. And if that's the case, when the light pops out the other side, it continues on as the rate of speed it had before it went through this slowing medium.
Right.
So how does it speed up? How does a particle that's just being shot at like a cannon from a source go through a medium, slow down, and then when it pops out, shoots back up and starts going at the rate of speed it was before?
Because
it doesn't make sense.
Particle, it's a beam. It is an instantaneous connection, or seemingly
It's not an instantaneous connection because it has a speed. It has 186,000 miles a second speed limit. This rate of C.
Says who?
So it's
Einstein.
Not,
so Einstein says light has a speed
says
limit.
the quantum people. I mean, this is what they say.
They don't.
This is not
quantum
new.
people.
No,
Quantum
they
people.
don't.
Quantum people.
That's not what they say. Non-locality, instantaneous action. That's not a speed limit. It's instantaneous. It does away with any idea that there's a speed limit.
Okay, no, that's a different thing. I see what you're saying. You're talking about the spooky action, as they call it. That's
Yeah.
hold on. I gotta get some coffee. Give me a second. Let
non-locality.
me
Spooky action. You're
purchase this
talking about
coffee.
spooky action at a distance is a Newtonian concept. We're talking about non-locality, not something unexplainable by Newton. An established
Right.
principle in quantum mechanics. Non-locality.
By the way, can anyone give me a link to
What?
what you guys are saying that light travels speed of light, passes through a medium, and then changes speed to a slower speed. Then after it's passed through that medium, it speeds up. Can someone send me information on that demonstration?
This is like a known thing. It's not
Well,
a made up
good,
thing.
because
So
I'm trying to look it up through Google and I can't find it. So please, that's why I'm asking you.
okay, well I'm in my car and I'm signing the dollar tip for my coffee. I can't do that for you, but I will definitely do it for later if you like.
How
But
about
there's actually like
keywords? Can you give me some keywords?
just say why does light change its speed through different medium without breaking law of conservation of momentum? Simple as that. Oops. Okay. Put myself on mute.
I know I'm fascinated about the question myself. I can't wait to look into it. Just sounds interesting.
I can't answer it. I can't tell you why a light will travel through a glass of water and then speed back up again when it leaves the other side. I don't have an answer for you. I'm sorry, Anon.
It's
Can I
ether.
answer that?
The ether
Because no, it's not that. Thank you. It's
Maybe.
not that. It's the rate of induction. Nathan, just imagine a puddle, okay? And then at the end of the puddle of water, there is like something more viscous, okay? And you throw and then after that, just bands. So you have a band of water and a band of viscous liquid and a band of water again. So what you do is you drop a pebble in the water and you see the ripple, the wave, go at a certain speed of induction. That's the transverse wave that's moving through the medium. And it goes at a certain speed. Then it hits the molasses. Then it hits tar, whatever you put there. If it was actually viscous enough, you still see the ripples, but the ripples will be a little bit slower to propagate. And if it manages to pass all the way through the band of molasses and get to the other side where there's water, then it speeds back up again. As soon as the water gets touched, the rate of induction will be the same in water. So that's why it's a wave. That's why it makes sense to me that it's a wave and it's not a particle, because the rate of induction, it's a rate of I don't want to say the E word, but it's the rate of induction through a medium. That's all it is. That's how it speeds up. If it was a particle, then you're gonna have to give it a bicycle pedals, or you gotta give it some engine, or you gotta give it something, because it needs to speed back up.
Real quickly, Nathan, when you in your chat for YouTube, you want to make sure all URLs are encased in quotes. So
Say that again.
begin quote, the URL, and the end quote, so people can.
What have I done
So the
wrong?
link
I
works.
don't know what I've done wrong. I'm sorry, but you'll have to be more specific.
So the link that you're providing in your YouTube chat,
Yeah.
just encase that in begin quotes and end quotes. Just put quotes around your URL, so people use it. Because if the URL is too long, the way YouTube does it, it concatenates. So, or if there's spaces in it or whatever it is. So it just you're gonna have people join from the YouTube chat. Just if you put a URL, just put it in quotes.
The one that's literally being used to speak, so that's the one I've got. If there's something wrong with it, I'm sorry for the people who tried to join and can't. It's my bad. I don't know what. I'll put it in quotes though. I'll copy it, stick it underneath the video, and then put it in quotes in the chat.
All right, and so I did find a Cornell.edu just snippet about talking about it, and yeah, okay. The thing is, I don't see a demonstration or experiment. It's like a very, very vague, abstract.
Read their explanation. I can. If you
Okay,
could read
so
it, that'd be awesome.
I'll go ahead and share it. Give me a second here, folks.
see if that works. Hopefully it will. I've stuck it in the chat in inverted commas. Hopefully that'll work. We'll soon find out.
Is that? Do you guys see that? No. I
Yeah,
think I shared the wrong thing. Give me a second.
Yeah.
Crap. Something. Now it's hanging. Hold on.
I think it's a broken Hangout today. I don't know how you guys have got to join, but there we go.
Okay, it's still hanging for me, but you guys can see my screen.
No, we can't.
Just read it.
Okay. Well, all right, I guess I'll read it until I'm out. It says there's a question. Is the speed of light constant? So the question is, my concern is about the constancy of c, the speed of light, as it goes into a denser medium than the medium it was previously traveling. The light slows down and it bends as a cause of this. This seemed contradicting to me that the speed of light is constant and yet its speed varies in different mediums. Why isn't c constant in all mediums? And does this variation of c in different mediums mean in any way that time flows differently in different mediums?
It also didn't. It didn't. That's not exactly my problem with it. The problem is that after it slows down, then when it goes to the regular medium, it speeds back up again. That's the issue.
Okay,
So
but the answer.
Will
you please let me finish? The answer goes into a little bit more detail than just that question. So the answer that this person gives, and the person's name is Sabrina Steerwatt, who's a graduate student at Cornell in 2009 and is now a researcher at Caltech. So she says, you are correct that talk of the speed of light can be misleading. When we discuss the constancy of c, we mean the speed of light in a vacuum. Since interstellar space is very empty and much like a vacuum, astronomers usually don't have to consider the speed of light in different media. However, the speed of light is not constant as it moves from medium to medium. When light enters a denser medium, like from air to glass, the speed and wavelength of the light wave decrease while the frequency stays the same. How much light slows down depends on the new medium's index of refraction, n. The light speed in a medium with index n is c over n. The index of refraction is determined by the electric and magnetic properties of the medium. For air, n is 1.0003. For ice, n is 1.31. And for diamond, n is 2.417. The bending of the light you mentioned upon entering a denser medium is how lenses work. Although the speed of light is no longer constant when we think about different media, we do know that light always travels fastest in a vacuum. Nothing can reach speeds faster than c. Well, not exactly true, so here for more details. Thus, from our equation, v equals c over n, n must always be greater than 1. Light moves slower through denser media because more particles get in its way. Each time the light bumps into a particle of the medium, the light gets absorbed, which causes the particle to vibrate a little, and then the light gets re-emitted. This process causes a time delay in the light's movement, so the particles there are, the more dense the medium, then the more the light will be slowed down. That's it.
Okay, it still didn't explain how does it speed back up. That's why I stopped you at the beginning, because I knew this wasn't going to address that. The addressing is, yes, I know it slows down, but what happens when it leaves that slowing denser medium and then hits another medium? It speeds back up again. How does a photon, a fundamental quanta, speed back up again after it's slowed down? That's all I'm trying to figure out. Without an engine or a pedal.
It says when it gets...
You know what? Hold on a second. Let me just interject a thought. Could it just be the appearance of slowing down, but it's not slowing down really? So that it just appears that when it hits that other medium, it's not really slowing down, but to the eye or to the measure. You understand what I'm saying?
I honestly don't. It slows down.
Right. No, think about it like this. Okay. You got your air, then you got your molasses, and you got your air again. What I'm saying is that, is it possible that the molasses is just giving the appearance of slowing down, but it's not slowing down really? That's just a question that's coming to my mind.
Well, another thing is speed of light is so fast that how do they measure the acceleration of the speed once it leaves that second medium?
Hey man,
See what I mean?
you're telling I had never clocked a light.
Yeah,
So
so
I
that's
can't.
why I want to know more about
186,000
this
But
demonstration,
what
this
I'm saying
experiment.
is, the theory that has put forth for me to consume doesn't make sense. That's what I'm telling. That's what I'm saying. I'm not saying I've done this. I'm
Well,
not
that's
saying
a
I'm
theory.
telling
Yeah, it
you.
doesn't make sense to me. I don't accept the theory.
Okay,
I accept the
that's my
observation and the measurement.
okay. What I'm saying is, when they try to explain the model, quote unquote, with a fundamental quanta, a particle that moves through a thing, and then it's like it's a thing. It's getting shoot. It's like a cannonball. It's getting shot at. Okay, with that, it doesn't make sense when it has to speed back up. But what I described with the wave and the rate of induction of basically light not being a particle, it's being a wave of whatever medium it is that is vibrating, both transversely and compression and rarefaction, meaning like a slinky. So not only it's transverse, like going up and down, but it's also like a spring getting put. I'm doing it with my hand, getting compressed and non-compressed, compressed and non-compressed. That is what a wave is, and when the property of a wave, I could see how it would be at a certain speed in one medium, hit another medium, slow down, and then as soon as it touches the other medium, the rate of induction will come back to what it was, like the water. So it makes sense to me as a layman monkey. It makes sense that it's a wave, not a particle, because the way they explain it as a particle breaks down as soon as that light particle starts speeding back up without an engine or a pedal. That's my fundamental problem with this.
So it sounds like the whole idea of light travelling at a speed is the convention you're working within, and then describing it as slowing down, which is Slick's point, and then speeding back up again, which is a convention that might not necessarily apply. The other
That's
problem
based
being,
on quantum mechanics. That's the whole thing of quantum mechanics. That's came up with this quanta. That's who came up with the fundamental particle of light.
yeah, and what I'm saying is the idea that slowing down or speeding up might not necessarily be the case. I don't know the answer, but I'm just saying you're working within a convention in terms of how it speeds up and slows down. Well, that might not necessarily be the case.
Yeah, I mean, we need to look more into the details of the demonstration and how they measured it.
Hey, I don't agree. It's a particle. So for me, it makes sense why it would slow down as a wave and then speed back up at a different medium. I don't have any issues with it. But if you believe that it's a particle, then sure, you have to look into it and try to make it work in your model.
It can only be a wave if you have ether.
Say that again?
It can only be a wave if it can travel through a medium you invent. So that the problem of when you don't have a medium and you can still see things, that's a problem that's addressed with ether.
Yeah, you can say that. So we both have problems with our system, but you subscribe to one and I subscribe to the other one. It's okay. I still love you. No issue. But what I'm saying is they both have problems.
I don't subscribe to one. One is bollocks because you have to invent a medium for a mathematical reification of light travelling through a medium as a wave to work. The other actually measures quanta hitting detector plates in real time.
No, the other one requires the quanta to slow down and speed back up without an engine.
So again, you're back into your convention, aren't you? This convention that you hold so dear to, that doesn't work because that convention requires a medium.
I don't hold dear to quantum mechanics. I'm not. I don't understand that. Both. You either have to believe in the ether or you have to believe in a quanta that speeds back up with an engine.
They're separate things. It's not one or the other.
I know you have to subscribe to
You're
either
equivocating. If you know, then why do you keep saying you have to choose one or the other?
Because you do have to choose one or the other.
No, then why are you saying no? You don't have to choose one or the other. Now you're saying we have to choose one or the other, and I'm saying no. They're not the same thing.
I know, that's what I said. They are not the same thing, so you have to choose one or the other.
Yeah, I choose the one that doesn't need a medium to be invented, that doesn't exist in order for it to be valid. The other being something that's actually physically measured.
Well, I choose a beam, an instantaneous connection.
Oh, right.
They have property deviations by going through mediums, by being touched upon by other things. But I think that is a solution.
Okay.
Because a wave does need to propel in a medium, like a ripple has to be propelling in water. And yeah, that's problematic. But if it's just a beam, an instantaneous connection that can fracture and can displace, it's still an instantaneous connection. I think that makes much more sense to me. No weird probability stuff, no misassumptions of any particles. There's only the critical mass, and yeah, and below that, it will not be registered. That is all.
But
But it is,
all
it is
quantum
particles.
mechanics
That's
is
what they're
trying to-
measuring. They're measuring particles. That's what they're detecting, and that's what gives validity to the experimentation that has driven us on, technologically speaking. So, as I say, you can try and pull it apart, but that's precisely what they're measuring. The particle physicists, when they measure the particles hitting the detector, not waves.
Right. So could they
But here's the
technically
thing:
send 1.5 particle of light in quantities? Or would it be numerical specifically to a specific type of quantity? Not the minimum quantity, but the total quantity of light. That's why I'm saying the particle, the unit, is an assumption based on the minimal registerable light.
Okay.
Doesn't mean it
the
is a unit that can be it can be multiplied and you can only divide by that unit quantity.
but the thing that's hitting the detector is a photon.
No, it's light.
Yeah,
No,
a photon of
Nathan,
light.
No,
Nathan,
a photon is an
the
assumption of a
photons-
particle form of light.
Imagine it's literally the interference pattern that we talked about. It's basically the points where waves interact. They have a hotspot, and then there are parts where they cancel each other out. So the parts that are the two waves that are coming and they interact, depending on how many waves, quote unquote, photons you shoot and how many slits, these create, which would, but it's just the interaction of hitting that photo plate. I'm in a tunnel. I don't know if y'all hear me.
So it sounds like, again, you're equivocating. So when they describe diffraction, the interference pattern, that's what you observe when you don't know which slit it's going through. That's the diffraction that's being described.
No, here's a question.
You're breaking it really badly, Anon. Oh, well, that's the end of that conversation,
Okay.
it seems.
Yeah. Look, all I'm trying to say is there's different branches off of quantum mechanics. Look, we're quantum mechanics, we're just trying to observe and measure everything and break it down to as small as where we can observe and measure it. When it goes off into other things, that's where you get into theoretical physics, and thus it branches off to things like quantum electrodynamics and whatever it is. Now, there's measurement problems even within quantum mechanics because they're trying to see when a wave function collapses and things like that, and so there's a lot of that goes into the realm theoretical, and that's where I
No,
don't
it doesn't. That's
subscribe
wrong.
to.
They know the cause of wave function collapse. They've established, that's what they've established. That is the cause of the effect. Knowledge of the which path. That is the cause. They have established the cause through scientific experimentation. Knowing which
Sorry,
path
I
it
wasn't-
goes through is what causes the diffraction to collapse in on itself and give you the straight line. That's what causes it. Having a detector there in the double slit experiment, knowing which path the photon travels through, causes it to collapse. Not knowing gives you diffraction, gives you an interference pattern.
Sorry, I was in a tunnel. I was in the center of Earth. So
Sure you were.
I didn't hear you guys.
Searching for the
No,
core.
I'm serious. I was breaking up, and then nobody could hear me, and then I couldn't hear you guys. Anyway, I popped up the other side. Did you ask me something?
Well,
No, we were just carrying on the conversation. I mean,
but
we're all pretty much
like the collapse is. I'm not saying the collapse doesn't occur. I'm saying how the collapse is measured.
Oh yeah, that was my
Is-
question. If they're comparing when there is an observer or when there is not an observer. If there is not an observer, then how do you know what you observed?
because you can watch it. You can see the
Then
interference.
there is an
because-
observer.
Yeah, you can still observe it all day long, yeah, and get the interference. The diffraction will still happen if you don't know which path it's passing through. So you can still see that interference pattern all day long because you haven't got a clue which one it's passing through, do you, just by standing there? So you can still see the interference. As soon as you put a detector at the slits to figure out, and then you know which path it's gone through, that is the cause of the effect.
What if the detector is the cause? What if, I mean, we're introducing a thing called the detector, and it's just a name to me. As far as mechanically, how it's involved, where it's placed, none of that is all it was basically a diagram with a thing called a detector, right? But we don't know what it did, so we've introduced a thing called a detector, and now our experiment is different. So, and now we assume that it's, instead of it being the detector, which is like, okay, well, maybe there is a reason why this is being caused, but now instead of saying that, we have to believe that somehow the photon knows what I'm thinking.
No.
Now, to me,
No.
that just sounds hocus pocus.
That's just nonsense.
Okay.
So they move forward. You figure out the cause of something, and it often, more often than not, raises more questions. So they come up with new ways of figuring out causes of effects. That's how you eventually go on to form scientific theory based on experimentation. That's where we get quantum mechanic theory from the experiments. So in the case of your question about, well, could it be the detector? Well, they've moved forward with the I can never say this properly. The delayed choice quantum eraser. That's what you just watched about, right?
Photon. That gets there with a sister photon that finds out what the other photon is going to do before. Right? That one?
Yeah, I can't give you a summary of the delayed choice quantum eraser without it being on
Yeah,
screen.
my point is like this. It just seems to me to be lots of stuff that I cannot verify. I don't know what the detectors do. I don't know how they're detecting, and not only that, that's not the main issue. My main issue is that at the end you don't get something where it's
Yes,
like, oh, it makes sense. At the end, you get something that's like doesn't make sense. You have to do.
I've said this 5 times. It drives technological advancement. So it's all well and good
Nathan,
declaring that something
GPS.
like Cavendish is an experiment. It doesn't do anything. It doesn't provide anything. It doesn't drive humanity forward. True scientific discovery does. And when we tell you...
Nathan, they say satellites and relativity are required for GPS to work.
Not valid by scientific experiment, though, is it? Just a so story about a region that doesn't exist. Why are you equivocating?
Because we were comparing things.
Yeah, they're not backed by science, are they? So when we come to something that is backed by science and has genuinely driven humanity forward, you go, oh, no, I can't trust that the technology's come from that. Oh, okay, fine. Well, what am I supposed to say to that? Okay, fine.
I don't know.
It's the same as the Cavendish, even though literally no advancement in humanity whatsoever has come from that garbage.
I'm not talking about Cavendish. I'm talking about satellites and relativity, because those are required for GPS to work.
Not the same. Not backed by systematic experimentation, are they? Just declaration of contraptions, the technology itself, in a region that can't exist. It's not comparable.
Well, yeah. So the same thing with another thing is you're saying it's like Narnia. It's a place that doesn't exist. The same thing with time travel. So now with this delayed quantum effect or whatever, I have to think that a sister photon knew what his brother photon did in before time, before it. Like how I have to suspend logic. It doesn't make sense. The end result for me is to go, what? Even John admits it. It doesn't make sense. He's like, you call me crazy, but that's what the experiment shows. But
No,
the
it
experiment
shows
shows something
no,
that's like
no,
doesn't make
it shows
sense. It doesn't compute.
No, it shows that if the photon has been detected, the sister will automatically know that that is the case, even though it takes a longer path. So that's where the delayed choice part of it comes. It's nothing to do with time travel.
Well, okay, so the photons are talking to each other. They're somehow communicating.
Oh, so not anything to do with speed limits and everything to do with non-locality then?
Yeah, sorry.
Yeah, backed
You're right.
by experimentation. Experimentally valid.
But again, we don't know, we have no idea how these things communicate. It doesn't make sense.
You don't.
How are they communicating?
Yeah, but how of them communicating doesn't change the fact that they do.
Like I said, this is one of those things that your observed phenomena would be photons communicating with each other using all these detectors and stuff, all within a contraption built up by a gentleman that is in the Jesuit school. Like, you see what I'm saying?
Function collapse. So this isn't like somebody's just stumbled across a crystal and go, oh, look, there you go. Look, there's a diffraction pattern coming out the other side. I wonder why that happens. And then they suddenly stick a detector on it. It doesn't work like that. They've been studying light for a very, very long time. The science has progressed incrementally in terms of what they're trying to establish as the cause of each individual effect that they observe. So it's a progression in terms of scientific discovery that you can track back through its origins. So when you come to quite obscure phenomena that's being presented, yeah, you can observe these things in nature. It's easy to go away and create a diffraction pattern. It doesn't mean it's not occurring in nature. It's the very nature of our reality. That's the point.
No, we're talking about photons knowing delayed time. Sister photons know what the brother photon did or is going to do.
Yeah.
That's not observed that I see.
Yeah. So it doesn't matter whether or not the sister particle is going through a slit that's been detected. If the one that's been through it on on a shorter path has been, the other one knows before it's got to the end of its path.
How?
I don't know the answer to that. I don't know the reason. I just know that
So
it
it's
does
magic.
happen.
To me, it's magic. It makes sense. It doesn't make any sense. None of this stuff
but
makes sense.
here's the
What they
thing,
are trying,
Anon,
but that,
like,
hold on.
there's certain, I mean, you call
You're
it.
asking supplementary questions beyond the experimental data. So they're trying to figure out what causes the diffraction to collapse. What causes, mathematically talking, wave function collapse. What's the cause? Well, the knowledge of which path that the photon goes through. That's the cause.
Anon keeps saying he doesn't understand that happens. Can't understand that's what's happening. Or
It's
he
not
doesn't
that
understand
I don't
why
understand.
it's happening.
What I'm saying is, even the people who are telling you this are telling you that you have to suspend your logic. I'm not telling you should suspend your logic. They're saying if you want to believe in these kinds of things, you have to suspend logic.
No. They are extrapolating out off the back of the experimental data. We're focusing on the experiment itself and the conclusions it comes to. Now, from there on in, people can flap their gums about all kinds of crap. Who cares? What they say are the implications, or what they theorize are the reasons for why they are communicating, if you want to put it into another concept. You know, they're not talking to each other, as far as I'm aware. These photons haven't got lips. They haven't got a little modem to communicate with each other. I don't know that bit, but that's outside of the investigation being done. They're trying to find out the cause of the wave function collapse. That's it. It's limited. It's very narrow. So all these extraneous questions that you have, superfluous to the actual experiment, I can't give you an answer to that. I'm sorry. Maybe they'll go forth because normally it raises more questions. And then you have to go forth and try and explain the answer with new ways of inquiry, not necessarily always scientific. And when you get into philosophy and theory, not scientific theory, i.e. Mystic Meg theories off the back of it. Oh, have we got Anaconda B joined? Anybody see that? Is this going to be the end of the show? Right in an hour anyway, so I might use that as my opportunity to round out the live show and say, if you are watching this on the Nathan Oakley 1980 stream, then stay tuned, as there will be an after show to follow. However, if you're watching this on Nathan Oakley channel live, then unfortunately this is where we bid you farewell. Massive thank you for sharing, hitting the super chat, subscribing, liking, all that good stuff. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!